Then we go to question number 6. So in the question number 6 we have yellow light of wavelength 589 nanometer is used to view an object under a microscope. The objective lens diameter is 9.00 mm. So I'll just write wavelength as lambda is 589 nanometer. Diameter of lens is 9.00 m. So first, what is the limiting angle of resolution? So I'll just go and see the formula given by Junior Tutor. So the formula for limiting angle of resolution is theta min, which is 1.22 times lambda over d. D here is diameter and lambda here is the wavelength. So for A part, we have what is the limiting angle of resolution. So this theta is the limiting angle of resolution. I can write theta min as 1.22. Then this will be 589 and nano is 10 power minus 9 over diameter is 9.00 mm into 10 power minus of will be 10 power minus of 3 to keep it in SI units. Then let's just see this conversion is correct. I'll just calculate the value using my calculator. So 1.22 times 589 10 power negative of 9 divide by 9 times 10 power negative 3. So this is 7.984 into 10 power minus 5. So this is 7.984 into 10 power minus 5 radians. So the minimum angle for resolution is 7.948 into 10 power minus 5 radians. Now, limiting angle of resolution, B part is, suppose it is possible to use visible light of any wavelength. What color should you choose to give the smallest possible angle of resolution, and what is this angle? So for in the visible range, I think the minimum wavelength of light is 398, or it is 380 nanometer. So from the equation above, the limiting angle of angle is directly proportional to the wavelength of the light. Therefore, to have the smallest possible angle of resolution, we need to use the smallest wavelength of visible light, which is the violet light with the wavelength of around 380 nanometers. So in case of B, we have lambda as 380 nanometer, and then we have diameter will be same, this will be 9 mm. So I'm going to use the same formula, which is theta min is 1.22 times 380 and converting back to meters over 9 times, again converting back to meters. Then I'll use my calculator. 380 times 10 power negative 9, 1.22 times 380 times 10 power negative 9 divide by 9 times 10 power negative 3. This will be 5.11 Why this 3 came down? I'm not. Oh god. Yeah. So this will be theta min for minimum wavelength of visible light is 5.1511 times 10 power negative of 6 radians. So again, the solution given by junior tutor is correct. Now we'll go to C part. Suppose water fills the surface between the object and the objective. What effect does this change have on resolve? 589 nanometer light is used. So for C part, here water is filling the area space between object and objective. So for this we have a formula. I'll just copy this formula from the formula given by junior tutor. So let's read the answer given by junior tutor first. So suppose water fills the surface between the object and the objective. The wavelength of incident light will change because of the medium. This we know from refraction phenomena. So this change in wavelength is lambda w given by, so we'll have lambda w given by lambda over nw, and lambda w will be the change in wavelength. I'll just say as new wavelength. Then nw is refractive index of water. I think, yep, is refracting index of water. Index of water, and lambda is again going to be 589 nanometers. So I'll just write lambda w as 589 nanometer over 1.33. 589 over 1.33, 442.85, 442.85. The junior tutor has taken till, okay, so I'll take till 3 decimal places, nanometer. 442.857. Oh god, I have to take till 4 decimal places. 2 times lambda. Here the lambda is going to be our lambda w, the new lambda which we obtain after dividing it by refractive index of water, and d is again going to be 9. So this will be 1.22 times 442.8571 times 10 power minus 9 over 9 times 10 power minus 3. So this will be 1.22 times 442.8571 times 10 power negative 9 over 9 times 10 power negative 3. This will be 6.003 times 10 power minus 5 radians. So let us see the solution given by junior tutor. Okay, So as seen from the answer, the recomputed limiting angle of resolution decreases, thus the resolving power increases. So again, the solution given by junior tutor is correct. Correct solution. Great job. This was my question number 6.